show for each y in B, really meant to underline that. Let me get my pen out. For you have to show that there exists an x in A so that f of x equals to y. That means that the arbitrary value is going to be the y in B. You don't get to make anything special for it. What you're going to do is solve for x as a formula of y. So x is going to be some formula depending on y. Any questions on that? You have homework problems like that. So let's go back and look at our next example. Consider the function f that's taking the reals to the reals, where f of x equals x plus 2. Is f onto whenever f of x equals f of y, then x equals to y. And the steps to be able to prove it, jumped too far. The steps to be able to prove this are you're going to let x and y be in A, such that f of x equals to f of y. So this is all the hypothesis. This is the baby hypothesis. That's what you're always going to assume. And then you're going to show that x equals, and this is by algebra. Those are our steps that we're going to be dealing with. I have a setting messed up on my computer. It's not letting me do an infinite scroll on the pages. I don't know. Oh, it's right there. There we go. Okay, let's look at an example. Let's consider the function that takes the reals defined by f of x equals to 2x. Is f onto the reals? Well, okay. So if it is, then let's choose some y in the reals. And what value of y gets mapped to y? So then our scratch work would be, okay, we want 2x equals to y. Solve that for x. What would x have to be equal to? How about y over 2? Okay. Well, if x is equal to y over 2, x equal to y minus 2 is in the reals.
Wait, in the copy is below onto the right there.
So is it onto? No, not onto. How would we show that it's not onto? Yeah, give an example that fails. So image in the integers. No, I want a number, not a formula. 3. Three images are even. Is f 1 to 1? Remember, 1 to 1 is a horizontal line test. If you have something of that formula for x, plug it in to show me that you get y when you're done. That's all you're doing. Now let's go back and same y. That means it's not 1 to 1. So think about your function 2x. What kind of shape does that function? It's a line. Okay. Can you draw a horizontal line and cross your line more than once? No. So it's probably 1 to 1. So how would we prove it? Yep. examples are when you're proving something false. So the steps, if you go back and look at that first page, what are the steps to prove injection? Yeah. Let x, y be in the integers such that f of x is equal to f of y. Well, what does that tell you about x and y? F of x is equal to 2x, right? So we're going to let our x and y be in the reals because that's a domain, such that f of x is equal to f of y. Notice that that's the same sentence right up here, except I changed what the domain was. That's really going to be the same sentence all the way through. And then the next step is to plug it in to see what it's equal to. So what is f of x equal to? My formula, x plus 2. So I write f of x is equal to x plus 2. But I'm assuming f of x equals to f of y. And what is f of y equal to? Y plus 2. Solve x equals to y. And so we see that f is 1. If you write as desired, then that tells people to go back and look at the original quite the entire theorem back out on these little ones. That's often what we do. Any questions on that? Okay, the next one, much more entertaining example.
Is that only the function that can be 1, 2, and 1 to 1?
No, you can have like square root functions, but you have to restrict their range and their domain and stuff like that. So you can have some restricted functions that are 1 to 1 and onto. A cubic function is 1 to 1 and onto. Any odd power, yeah, it's the even powers that you have to restrict them. Yeah. Exponentials are 1 to 1 and onto. You just have to restrict the domain for the logarithmic functions. Yeah.
How about like tangent,
Tangent.
can be right?
Tangent is it's 1 to 1 and onto from minus pi over 2 to pi over 2 because it has vertical asymptotes. So you asymptotes from the domain and then get rid of everything where it's repeated. So restrict it. Arctangent it works for all x, but the y's goes minus pi over 2 to pi over 2. Yeah. So the trig functions, you have a lot of restrictions going on. Okay, look at this function. This one's quite a bit different. It takes a point, x, y, and it gives you x times y. This shouldn't look too... So we need an x, y in the integers such that f of x is equal to f of y. Just applying the definition of f, and I'm going to put this on display. You're going to have 2x is equal to 2y, but 2x, I'll put this, that's equal to f of x. X we're assuming is equal to f of y, which is equal to 2y. Divide both sides by 2, and you have x is equal to half the class. In theory, there's supposed to be 8 people in this class.
Oh, I always forget that he's actually in this class.
Yeah.
Any questions on that? You have homework problems like that. Okay, so let's go back and look at our next example. Consider the function f that's taking the reals to the reals, where f of x equals x plus 2. Is f onto That's where that's coming from. Or if you know Spanish, it's, I think, similar in Spanish. French and Spanish are very similar. If you speak Spanish slowly, you can understand it. They're both Romantic languages, and they're Latin-based. And they have very similar Portuguese. Oh, okay. I didn't know that. I knew Portuguese was related to Spanish, too.
Oh,
Yeah, Portuguese.
because
Italian,
Portuguese is
Spanish.
just maybe
Okay.
But they're not.
there's.
It's not going to be identical, but it's similar enough. And if you want to restrict yourself in French to words in English that are 4 syllables or more, they're usually going to be the same meaning in French. You just have to sound them right, you know.
Yeah. So,
Yeah, exactly. But they're usually the same. At least that was my take on my 1 year French.
even the word control is in French, control.
Oh, yeah. And with computers, it's the same. They just pronounce it different. Yeah. Okay, back here. So we want to show it's on to, is it 1-to-1? Yeah. So we have to come up with 2 different x, y values that have a z value. So m of 1, 2 is equal to 1 times 2. 2 times 1 is m of 2, 1. So it's not 1-to-1. Because it's not equal to 2, 1. But it is onto. So how do we show onto? What is the range on here? The integers. So we have to get something in the integers. What would you like to call it? Okay, let's C be in the integers. What do we know that gets mapped to C?
That's something like design C.
Okay, one of them is C, then what would the other one have to be? 1. It has to, in particular, has to be 1. 1 is equal to C. And C1 is in Z cross Z. So M is on 2. Okay, how did that work? Plug it in was not on 2, was 1-to-1. This one is 1-to-1. I mean, is on 2, but not 1-to-1. It's the opposite of the first example. Surjection and onto is the same. Let's go do our proof for this one. Yeah, f of x equal to f of y. Plug in what that means. In this case, that means so which one do we want to do first? Onto or not 1-to-1?
Onto.
You want to do onto first, okay? So we're going to let our x and y be in the reals because that's the domain, such that f of x is equal to f of y. Notice that that's the same. I have the same sentence right up here, except I changed what the domain was. That's really going to be the same sentence all the way through. And then the next step is to plug it in to see what it's equal to. So what is f of x equal to? My formula, x plus 2. So I write f of x is equal to x plus 2. But I'm assuming f of x equals to f of y, integer by integer, xy plate, x integers and y integers. And this satisfies m of c1 is equal to c times 1, which is equal to c. Therefore, the preimage of, I should say a preimage of c 1. And any questions on that? Now we're going to show not one-to-one. How do you show not one-to-one? Yeah. Well, note that because we know, yeah, 2, 1 is in integers cross integers, right? I have it set as a shortcut.
For ours, it's just control S.
Oh, I didn't know that.
Yeah,
That's the setup. I didn't take time to learn them all. So 2 z cross z and, well, I'm going to put them both in here. You can make a comma delimited list to be an element. You know, m of 2, 1 is equal to 2 is equal to m of 1, 2. Right? And so m is not 1 to 1. So we're done. Any questions on that? Your first, I think, x times y. This shouldn't look too to those that we have just done right here, showing 1 to 1 and 1 to 2. Can we do that? See, z equals x times y as function. So you have, this is a 3-dimensional function. You're taking your xy plane and you're putting a z point someplace for it. A onto B, and G takes B onto C, then G composed of F takes A onto C. How would we? Yeah, 3. Let F, well, we'll just write A onto C. That's all we need. Yeah, and G take B on, oh, A onto B. Yep, and G takes. We want to show that G composed of F is onto. How do we show onto? It's always a good thing to be happy. Go on to, we're going to let C be in the final, in the range. Find an A in A such that G composed of F of A is equal to sur in French is on. That's coming from, or if you know Spanish, it's I think similar in Spanish. French and Spanish are very similar. If you speak Spanish slow enough, a French person can understand it. They're both Romantic languages and they're Latin based. And they have very similar Portuguese. Oh, okay. I didn't know that. I knew Portuguese was really. G composed of F of X is equal to G of F of X, right? That's what it means. And so we have G of F of X equals to C is what we're looking at right here. G of F of A is equal to C. Well, what is F of A? Where does, question this way, where does F of A live? Mm-hmm. Anything dealing with computers, it's the same, they just pronounce it different. Yeah. Okay, back here. So we want to show it's onto. And so you have G as something and B has to be equal to C. So what we're going to do is apply the fact that G is onto. And we're going to go backwards. Since G is onto C, there exists a B in B such that G of B is equal to 1 times 2. That's our definition of onto. Because E is in our capital B and F is B. But it is onto. So how do we show onto? What is the range on here? The integers. So we have to get something in the integers. What would you like to call it? Okay, let's C be in the integers. What do we know that gets mapped to C?
That's something.
Okay, one of them is C, then what would the other one have to be? 1. It has to, in particular, has to be 1. 1 is equal to C. And C1 is in so our first example was not onto, was 1-to-1. This one is 1-to-1, is onto, but not 1-to-1. It's the opposite of the first example. Surjection and onto is the same. Yeah. So let's go do our proof for this one. Do what? Oh, you don't want me to make it go away yet? I am pretty quick at that. And we need to write down what this goes from. Then it's going to take the integers cross the integers to the integers. So which one do we want to do first? Onto or not onto one? Yeah.
I'm gonna be a really slow teacher.
Do what? We're in the chemistry room, in the big amphitheater. In calculator. And my handwriting is especially horrible today in class. I don't know why. Well, part of the reason is the board was dirty, and so
It was really dirty.
it was, and I couldn't get it to come clean. I tried. Well, they just need to clean it. Rubbing alcohol will take that off. But yeah, and the next lecture and talk to will be a little bit long. The last one's not bad at all. Last one's really
You
simple.
lecturing? Yeah.
I'm back to that. No, I remember in the videos I ended up having to do a lecture anyway. It was just I limited it to about 15 minutes. So why lecture twice? Why not just lecture once?
Wait, so you want to do the
Yeah,
Yeah.
that's how we taught. You don't do the. How they do extra credit. We take notes in class and she's like.
I'll tell them what the extra credit is, and so they have it in class. And all those notes are posted from that you guys had
Yeah,
online.
all of the lectures.
In this class, you can go watch them. So yeah, and if anyone wants to watch them later, they can. I know people do watch them because I don't know who, but I do see how many. Okay, so theorem 7. If F takes A to B, G takes B to C, and G composed of F is on to C, then G is on to C. So how would we prove this one? So first of all, what's the hypothesis? We want to show that G is on to C. So how do we show that G is on to C? C and find X mapped to it. I can't put that in the small homework problem. Is so that's what we're trying to do. So let's write it down here. Hopefully, it'd be an element in C. Well, we have 3 things that they gave us in our hypothesis. These are G composed of F. G composed of F is on to C, so what does that tell us? How would we prove that? Such that G composed of F equal to Y. We know about G composed of F of X. Okay. So G composed of F of X is equal to G of F of X. What do we know about F of X? Where does it live? Yeah. Now, F of X is equal to some B in B by definition of F. And so G of F of X has to be equal to G of B is equal. What is the definition of function composition? Yeah. Okay. Then I should use a better word than that. So implies that G is onto. Well, G of F of A is equal to C. Well, what is F of A? Where does, maybe I should ask any questions on that. Let me scroll it up so you guys can see it a little bit better. Where does F take value? B. So F of A has to be someplace in B, right? And so you have G as something in B has to be equal to C. So what I'm going to do is apply the fact that G is onto. And we're going to go backwards. Since G, yeah, that by substitution, put that in here. Good call. Except, let's just do extra line. And then you know that G is on to C. Because Y is in C. Yep. of A is equal to, it says if F takes A 1-to-1 to B and G takes B 1-to-1 to C, then G composed of F is 1-to-1. What's the hypothesis? F of A. Well, F of A is equal to B. G of B is equal to C. Tells you that A is 1. Yeah. Let X and Y be in A such that G composed of F of X is equal to G composed of F of Y. Apply the definition for G composed of F of X. That means you're going to have G of F of X is equal to G of F of Y. Now, you know G is 1-to-1. And you have G of something equals G of something. So whatever is inside has to be equal. You follow that? G is 1-to-1. Whatever is inside the G functions. And those markers are really fast on the chalk on the whiteboards. They're faster than chalk on the blackboard. So you can write a lot faster as a teacher. Yeah.
I'm gonna be a really slow teacher.
Do what? We're in the chemistry room, in the big amphitheater. Yeah, in California. And my handwriting was especially horrible today in class. I don't know why. Well, part of the reason was the board was dirty, and so
It was really dirty.
it was, and I couldn't get it to complete. I tried. Well, they just need to clean it. Rubbing alcohol will take that off. But yeah, and the next lecture and talk to will be a little bit long. The last one's not bad at all. Last one's really simple.
You lecturing? Yeah.
I'm back to that. No, I remember in the videos I ended up having to do a lecture anyway. It was just I limited it to about 15 minutes. So
Oh,
no, this one's similar to
exactly.
3 of them ago that had the onto. The second one, if G composed of F was onto, then G was on. G composed of F is 1-to-1, then F is 1-to-1. The first one's 1-to-1. So you have 2 functions, F and G, and be 1-to-1. Show that F is 1-to-1. That's what we're doing. So what's the hypothesis? F take A to B, not necessarily onto. And G take A to C. Take A 1-to-1 to C. And you're trying to show that F is 1-to-1. So how do you show that F is 1-to-1? It's on our first page of our notes. How do you show something's 1-to-1? Yeah, F of X equal F of Y. So let X and Y be in A, which is the domain for F. We want to show that G is onto C. So how do we show that G is onto C? And littered with such .st all the way through. But yeah, it's supposed to for publication. But I let that in the small. So that's what we're trying to do. So let's write it down here. Display, you're supposed to use a double arrow instead of IFF. But that's a convention this book doesn't stick with, and I think that's where I would have corrected out long. Yeah, no, it's annoying. Okay, so let's continue. What do we know? F of x equal f of y, and we know G is 1-to-1 from A to C.
Just trace back previous one. Maybe back the one we just did.
Well, it's not quite backwards from the one we just did. We're actually going to do this one proof by contradiction because the direct proof doesn't work very well. Exactly, take this and plug this in f of x. What do we know about f of x? Where does it live? Yeah. Now, f of x is equal to sum b in b by definition of f. And so g of f of x has to be equal to g of b is equal to y. What if b is in b and g of y, then I should use a better word than that. So implies that g is onto. It's onto because the y was an arbitrary value. We found a value in b that gets mapped to it. Any questions on that? Let me scroll it up so you guys can see it a little bit better. Which part? Okay, so you okay. So what we're doing is you're just plugging in for f of x. You know that f of x, g of f of x is equal to y, and f of x is equal to b. So I plug that in for f of x to get g of b. From right here. Yeah, that by substitution, put that in here. I was assuming g was 1-to-1. No.
Assume that G is.
Assume that g is 1-to-1. Yeah, I don't think we can do that way. This is the last one. Let me double check that. Oh, we'll get it done. I can write really fast.
It's okay, it's outside is raining.
Just right over there.
Oh. Go back. Actually have. What's the hypothesis? And we want to show that G composed of F is 1-to-1. So show 1-to-1. Yeah. Let X and Y be in A such that G composed of F of X is equal to G composed of F is equal to G of F of Y, correct? Because G is a function. Now we have one more thing to apply and we're done. G is a function. It has to take the same value to the same value. And so G composed of F of X is equal to G composed of F. You know G is 1 to 1. And you have G of something equals G of something. So whatever is inside has to be equal. You follow that? G is 1 to 1. Whatever is inside the G functions. Now tell me about F is 1 to 1. Has to be equal to y. And since you concluded x equals to y, what does that tell you about G composed of F? Yeah, since x equals to y, F is 1 to 1. Yes.
There's that one, this one last.
Oh, did I too fast? Okay, our last one that we're looking at.
That's so similar to.
This one?
Oh,
No, this one's similar to
exactly.
3 of them ago that had the onto. The second one, if G composed of F was onto, then G was onto. Here, if G composed of F is 1 to 1, then F is 1 to 1. The first one's 1 to 1. So you have two functions, F and G composed of F is going to be 1 to 1. Show that F is 1 to 1. That's what we're doing. So what's the hypothesis? F take A to B, not necessarily onto. And G take B to C. Take A 1 to 1 to C. And you're trying to show that F is 1 to 1. So how do you show that F is 1 to 1? It's on our first page of our notes. How do you show something's 1 to 1? Yeah, f of x equal f of y. So let x and y be in A, which is the domain for f, such that f of x is equal to f of y. A short note, when you're writing things by hand, you can use shorthand notation. When you're typing it, you're not supposed to use shorthand notation. I don't know who invented that rule. I suspect it was some English person someplace, but they make us abide by those rules. If you were typing for publication, no. I had my dissertation littered with those, and I had to go take them all out. I also had them littered with such that ST all the way through. But yeah, it's supposed to for publication. But I let you use it for what we're doing in these classes. It's a very common shortcut. On homework, if you have it on display, you're supposed to use a double arrow instead of IFF. But that's a convention this book doesn't stick with, and I think that's where I would have corrected you. I don't know how long. Yeah, no, it's annoying. Okay, so let's continue. What do we know? F of x equal f of y, and we know G is 1 to 1 from A to C.
Just trace back.
Right backwards from the one we just did. We're actually going to do this one proof by contradiction, because the direct proof doesn't work very well. Exactly, take this and plug this into this function right here immediately. Okay, so what we're going to do is suppose x is not equal to y. If x is not equal to y, since G composed of F is 1-to-1, x not equal to y imply that G composed of F of x is G composed of F. Does that argument make sense? That G composed of F is 1-to-1, and you set the G composed of F of x equal G composed of F of y, then you know x equals to y. But we know that is not equal to y, then we can't have the images be the same, because that fails a horizontal line test. If you have some x here and some y here, have the images on the same horizontal line, that's not 1-to-1. But we assume that G is 1-to-1. So if x is not equal to y, then the images can't be equal. Does that make sense? Yeah. We can't have a horizontal line crossing the function more than once. But what does that tell us? G of f of x is not equal to G of f of y. We're not quite there. We have one more step.
Oh, therefore, f of x is not equal to f of x is equal to
Only if G is 1-to-1, but G they didn't tell us is 1-to-1. I might not be able to do it. I was assuming G was 1-to-1. No.
Assume that G is.
Assume that G is 1-to-1. Yeah, I don't think we can do that way. This is the last one. Let me double check that. Oh, we'll get it done. I can write really fast.
It's okay, it's outside is raining. It was like the whole day.
Just right over there.
Oh. Go back. I actually have this written in my book. Does not work. I did it anyway. Don't you like how my eraser works so slowly? Okay, so go back to right here. And it's one line after this. Let x, y be an A such that f of x is equal to f of y. And we're going to call that some, let's see, f is in b, some value b. Then g of f of x has to be equal to g of b is equal to g of f of y, correct? Because g is a function. Now we have one more thing to apply and we're done. G is a function. It has to take the same value to the same value. And so g composed of f of x is equal to g composed of f y. G composed of f is 1-to-1. That tells you x is equal to y. Since x equals to y, 1-to-1. As desired. Told you it was not long enough for that. I just went. That makes sense? Your homework is very similar, and they're important enough they make it on tests. So if you're starting to study for the test, I would start by memorizing these proofs. They're guaranteed you're going to see one, if not more, of them on the test. So might as well start memorizing them. Let's see.
There's that one.